Hello, welcome to Market Analysis of Urban Built Environments. This is Professor Grant Thrall. This is Module 2B, which will be in several parts. This is Part 1, Trade Area with ESRI Business Analyst. This material is based upon Grant Thrall, Business Geography and New Real Estate Market Analysis, published in 2002 by Oxford University Press. Hello, this is Professor Grant Thrall. This module of Business Geography is on calculating trade areas. This technology I'll be using is Business Analyst from ESRI, ESRI.com. We're particularly interested in this demonstration of North Florida and the surrounding areas. We're going to calculate a trade area around the main shopping center in Gainesville. Butler Plaza and Oaks Mall. Butler Plaza has about a million square foot. Oaks Mall is a regional shopping center enclosed with also about 1 million, and Butler Plaza is adding about 1.5 million square feet to their existing outdoor 1 million square feet of power center. And looking at where there are other competitive shopping areas near Gainesville, first of all, we'll create a database of competitive locations. I've already geocoded and imported those locations. What we need to do is to make them a bit more noticeable. You may not be able to see them, so I'm going to make our dots larger and perhaps make our color more vibrant. And there we are. There we have the shopping center that we're going to analyze. And then this is Butler Plaza, and Oaks Mall is at this location, and we're in the city of Gainesville. These two are in the process of being linked with a local access road. First, in Business Analyst, what we need to do is set up the store layer. And so I'm going to create a new store layer. I can geocode, I can enter the store's addresses. I already have map-ready data. I could use address coder, community coder. And I've already created this data layer. It's already in my map table of contents. Yes, it's found that Competitive Malls, North Florida, version 2. And what is the name of each store? These are my data attributes. Just say name. Find the store ID field. We'll just say ID. And what do I want to call this? Competitive locations. Competitive regional shopping. And here we have Business Analyst now recognizes as the location of the businesses. Next, I'm going to click the Business Analyst icon, or pull down menu. I've set up the store. I'm going to create an analysis extent, and I will have it as the current map view. And now I'm going to calculate a trade area. So I'm going to calculate a new trade area, And this is relevant for whatever GIS you are using. In terms of considering the analytics behind the technology, are we going to have a customer-driven trade area calculated, or do we not? If we don't have customer data, then we have store location data. So, and I'm going to pick select trade area method from the list just to show you the large number of possibilities that are included in Business Analyst. We can have, expand this outwards, no customer data is required for these first. Data-driven rings, non-overlap rings, simple rings, drive time polygons, that's what we're going to use. Threshold trade area, Huff equal probability model. That's a version of a spatial interaction model, which we'll deal with in another module. Standard levels of geography. We have grids, equal competition, Thesian-Voronoi polygons, subgeographies, distance decay areas, market penetrations, customer-derived areas. We could draw an area, trade area penetration. So we could go to any of these. What we're going to do is no customer data. First of all, I'm going to create a drive time polygon. Next, so I'm going to calculate drive times around each of my stores. Next. And here we have the closer customers are more important than distant customers. And the probability of a customer coming to your store is greater if they're close and is less if they are further away. So we can calculate 5 minutes, 10 minutes, 15 minutes. The International Council of Shopping Centers does have advice on what the drive time trade areas are for each category of shopping center. Super regional center. And so we would be looking at a trade area of about 45 minutes. For example, there's a Walmart and a Best Buy, and in some reverse engineering work that we'll look at in other modules that I have executed, I found that in a high population density area, such as in the San Francisco Bay Area, Best Buys, with a few exceptions, Best Buy tends to locate between 12 and 15 minutes from the store to the edge of their trade area. So we'd be looking at 24 minutes to 30-minute trade areas. So let's put down a 25-minute trade area. And then for a grocery store, which Butler Plaza also has, it serves as both a super regional center and also a neighborhood center with grocery stores. Then we'll put down 6-minute drive time. So we have 3 drive times here, and we can calculate that with the demographics within each, which is what the individual stores are interested in. We could calculate, for example, the total population, the total adult population, the total woman population, and certain age groups, whatever the value platform is of the store. And so we can determine if our threshold revenues are satisfied. Threshold revenues from central place theory, which we'll go through in another one of the modules. We'll just look at each individual polygon of 6-minute, a 25-minute, and a 45-minute polygon. For nice increments, we'll make this 5 minutes. 5 minutes, 25, 45. And we could even add more rings if we wanted to. And so I'm going to call this, I'm going to call this 5, 25, 45 minute drive. And I'm also going to create reports.